Good day, everyone. Today, I want to quickly explain to us how a three-phase changeover can be connected. It's a changeover switch and it's a manual type. How can we connect our three-phase changeover manual type? First of all, our three-phase changeover type comes in 4 poles. How many poles? 4 poles. The first pole is for neutral. The second pole is for line 1, third pole is for line 2, and the fourth pole is for line 3. Those are the 4 poles here. You can see the first pole for neutral, red phase, neutral pole, and the blue phase pole. So that is 4 pole. And another thing is that this changeover switch here can accommodate 2 sources. So this generating set serves as source 1, and the second generating set serves as source 2. And when we look at this 4-pole 3-phase changeover, let's say the pole 1, the first pole now. The first pole has 2 terminals. The first terminal in the first pole is for the line, that is line from the source 1. And the second terminal in the same pole serves as terminal for the load, which means in the second pole, line in, load out. The third pole, line in and the load out. Likewise, the fourth pole. So the same thing goes in the other source, because this is source 1 and this is source 2. And if you take a look at it, what is the relationship between the source 1 poles and the source 2 poles? Is this common? You can see there is a conductor here that is used to link the load terminal together. The load terminal for the source 1 and the load terminal for the source 2 are linked together by a jumper. At times it's made up of copper, silver, and so on, just to make the 2 terminals common for both sources. You can see in the pole 1 here, the load terminal is connected, linked with this jumper, this copper conductor, so that they are made common. So likewise in the second pole, third pole, and the fourth pole, the load terminals are common between the 2 sources of a changeover. So now, how do we now carry out the connection? In the first place, since we said it is 3-phase, and 3-phase changeover starts from 100 amps, 200 amps, 400 amps, and so on. And the higher the rating capacity, that is the current handling capacity of a changeover switch, the bulky the changeover is. Why did I say it becomes more bulky with respect to the rating or current rating capacity? It is because the capacity of the insulator to handle that amount of current will be higher, will be bigger in size than the capacity of the insulator that will be able to hire small current. And that is why high rating capacity changeover are more bulky than the low rating capacity changeover. So, and when you take a look at this, let's take a look at the connection now. The 3 wires coming from the generator 1, that is the source 1, they are the neutral, the red phase, yellow phase, and the blue phase. Those 4 wires here now, the neutral enters here, the first terminal in the first pole. The red phase enters the first terminal in the second pole. The yellow phase wire enters the first terminal in the third pole, while the blue phase enters the first terminal in the fourth pole. Now let us see what happens in the second terminal. You see, since this second terminal in the first pole, second pole, third, and the fourth pole, they are common with the other source pole. You can see this is the first source and this is the second source. The poles here and poles here, their load terminals are common. So since they are common, so they've linked them already right from the factory. So if we want to connect our load cable now, our sub-main cable that is going to the consumer unit, we are going to pick it either from the load terminal at the source 1 here or load terminal at the source 2 here. Wherever you pick it from, they are common. It is the same. I can decide to take this wire now to this point and pick it from here. Still the same thing. Since they are common, there is a jumper used to link them together. In the source 2, this is the source 2. The neutral enters first terminal of the first pole. Then you can see the red phase enter the first terminal in the second pole. The yellow phase enter the first terminal in the third pole, while the blue phase wire enters the first terminal in the fourth pole, just like we have it in the source 1 poles. Now let's see the load. The load now can be taken either from the upper poles or the lower poles, since they are common, you can see they are linked together and common. So let us see how we tap them out now. The neutral is taken from the second terminal of the first pole and connected directly to the neutral bar in the distribution board or our consumer unit. So let's see the red face, the load terminal. You can see the load terminal. The wire is connected directly to the red face terminal in the main breaker of our consumer unit. So let's see the yellow face load wire. Can you see? Let's see. Have you seen it? The sub-main cable here is connected to the yellow face terminal in the main breaker. While finally, the blue face load wire is connected to the blue face terminal in our main breaker. So you can see now, this is the neutral bar and this is the earth bar. So whatever we have here, we are going to connect this one to the earth. We are going to earthing the installation through this terminal, and all the earth wires are connected to this bar. So that is it. And after doing this, by the time we connect all this like this on all our cables coming from our load from each of the final sub-circuits terminated to our miniature circuit breakers here, the next thing to do is to put on all our load. When we put on all the load, keep all the load running, put on the AC, put on the water heater, all the lighting points, possibly all electronics in that building, let them come up. Then what you are going to do next is what we call load balancing. How do we balance the load? We're going to get our clamp meter, then adjust the knob to measure current. Then you are going to put your clamp meter around this wire here. So you are going to around this wire here to measure the current. Then note down the value of the current. Measure this current also on the yellow phase wire, and finally on the blue phase load wire. Note all the values of the current. At the end of the day, if the current in any of those wires is far ahead of others, try and change those loads, redistribute them, take away some load from the phase that has more load than the other, until you are going to have the values of current on each of the sub-main cable feeding the main breaker almost at the same range. For example, I have 21.6 amps here, and I have 19.5 amps in the second one, and I have 20.5 amps in the third one. You can see they are very close. In that case, we have a balanced load system. Do not leave your installation without balancing the load. So meet me in the second episode of this manual changeover system in my next video. Until then, I'm your one and only Engineer Oxford. I'm going to see you in my next video. Peace.